Evaluate the function when x is equal to -1, 0, and 1. A piecewise function is a function built from pieces of different functions over different intervals. When x is equal to -1, x is strictly less than 0. Therefore, for f of x, we're going to use the piece x squared plus 1. F of -1 becomes -1 squared plus 1, which is +1 plus 1, which is 2. When x is equal to 0, x is greater than or equal to 0. Therefore, f of x will be equal to x minus 1, and f of 0 is 0 minus 1, which is -1. And finally, when x is 1, x is greater than or equal to 0. F of 1 will be 1 minus 1, which is 0. Finding the domain of a function. Student may pause the video to review the definition of the domain of a function, which is the set of all possible x value that will make the function work. The first function is given explicitly. We are given a set of ordered pair in which x represent the inputs. So the domain of x is 3, -1, 0, 2, 4. The set of the first element. For g of x, remember that we cannot divide by 0. When we set the denominator equal to 0, x equal to -5 will make the function undefined. So the domain is all x different from -5. In other words, we can write it. The domain of G is the set of real number R minus the singleton -5. For the volume of a sphere, the variable is the radius. And we know realistically that the radius can neither be negative or 0. Therefore, r must be strictly greater than 0. And the domain is all real number r that are strictly greater than 0. The radicand 4 minus x must be non-negative, greater than or equal to 0 for h of x to exist. When we solve the inequality, 4 is greater than or equal to x, which means x is less than or equal to 4. On the number line, when x is equal to 4, h of x is 0, we are okay. And if x is less than 4, for example 3, we're going to have square root of 4 minus 3, which is 1, and h of x will exist. So the domain of h of x is all x less than or equal to 4.